Welcome back. In today's video, we are going to go over some basics of object-oriented design and kind of see why object-oriented design might be, kind of a better design for creating applications that are um, easier to maintain, easier to test, and, overall a better way to design than sequential or procedural design. So let's get started. So how do you design solutions to problems? And there are lots of different ways. And the traditional approach is kind of sequential. You sort of treat it as a recipe, let's say. You could also design using pattern matching, look for patterns that are similar to the problem that you're trying to solve. You can also plug and play. You can, try to get solutions from various places. And of course, today, a lot of you are familiar with ChatGPT and other AI tools. So you try to get them to solve and things like that. And I call it the plug and pray method. And you will see example of that these tools are not always the best way to solve problems. And of course, one of my favorite growing up was the Rube Goldberg method. So we try to put whatever we can find in our hand together to solve a problem. But in this class, we are basically going to try to find a good way to solve the problem. So let's take a look at the more traditional way of, and that's kind of the Python way of solving problems, doing things sequentially. Typically, when you are taking any Python classes, you're usually going to open up a Jupyter notebook, and you're going to essentially start calling functions one after the other, and kind of like that. And you would probably create procedures or functions in the middle. And but essentially you start from one point and go towards the your goal point. You may have loops, you may have things that you repeat and things like that. And there are real life examples. Like, for example, when you are in a car and you want to go somewhere, it is sequential. You're going from one place to the other, and you're going to have to make steps. You're going to have to decide what happens if you run into a situation, but you're always, solving one problem after the other, and you're going towards the goal. It's very sequential. Also, if you think of cooking with a recipe, that's also sequential. You start with your ingredients and you go one step to the next step to the next step and so forth. So those things are fairly sequential in a way. Procedure-oriented design, sometimes referred to as POP design, is where you identify some blocks of code or parts of your application that repeat. And when you do this, when you find something like this, what you do is you create a procedure, or in Python nomenclature, you create a function. And in that function, you put the type part of the code that repeats. And whenever you need that part of code, you call that function. So that makes it easier. You can sort of reuse parts of the code, makes it kind of like nicer. Object-oriented design, which is what we are going to review in this class and this sequence of videos, is where you do not worry about a sequential way of doing things. What you do is you try to identify different blocks of components that are part of your system. And then you try to figure out for each component, what do they do? What kind of things do they have? And what is nice about that is that every component can be developed independently, right? And we will see an example today where we can develop every little thing independently. We can test them independently. We can update them independently. We can use them independently. And then finally, what you do is you put all of those things together with a controller of some sort, and then you have your working examples. And that is the way most systems, like operating systems, for example, your desktop operating system, your applications like Zoom, for example, that I'm recording this on right now, PowerPoint slide that you're seeing, all of these are actually designed using object-oriented paradigm. And you will see why, because it's really a better way of doing things that you can repeat and you can continue building on as your requirements change. So what we're going to do in today's example is we're going to build a little counter. Okay, so it's got, you probably have seen one of these wherever. It's a counter. It's got two functions really. It's got one, this little button that when you press it, the count increases, and then there is this dial on the right that you use to set all the counts to zero. So this thing is of course completely mechanical. We're gonna create a digital version of this. So the first thing that we do is do sequential design. And let's try ChatGPT, right? So here is my attempt at solving this problem with ChatGPT. So here's the prompt that I gave to ChatGPT. Create a simple MicroPython counter application, runs on the Raspberry Pi Pico, and we're going to start getting into the Raspberry Pi Pico already. So today you will see we're going to build this thing on a simulator. We'll talk more about the simulator and the Pico as we go along. Today is just to show you what this looks like. So going along, application should use two buttons, a count button that increments the count by 1 and a reset button that sets the count to 0. Count should be shown on a 16:2 LCD display. Display is connected via to pin 0 and 1, and the buttons connected to pins 15 and 16. That is all I told ChatGPT. And ChatGPT beautifully pulled up, understood my requirements, and told me what libraries I will need and created this beautiful little code, right? And it's not very long. It's only about, I don't know, 20 odd lines. So let's take a look at the simulator. And this is the simulator that I really like using. It's called Walkwe. And the first one that we would use is this one. So this is the simulation, and this is exactly how ChatGPT asked me to do this. So if you see, scroll down and ChatGPT actually tells you that here are the files that you would need, and here is how you would need to run it. Here is how you would connect it. So you see SDI pin 0, PCI pin 1 to the LCD pins, pull down resistors for button on pin 15 and 16. And it actually gives you wiring. It tells you I2C LCD, it needs to go SDA to GP0, SCL to GP1, right? So that's what I did, SDA to GP0, SCL to GP1. Of course, it didn't tell you that you needed to connect the VCC and ground as well, but that's okay, we could do that. So this is the Raspberry Pi Pico. We'll talk more about these as we go along. And then ChatGPT also told me to the count button, one leg to GP15, other leg to ground. And that's what I did with a pull down resistor. All right. So one leg to GP15, right here, and the other leg with a pull down resistor to ground. Great. I did exactly what ChatGPT did. And it for the reset button, one leg to GP16, other leg to ground. One leg to GP16, the other leg to ground. And then when I run this code, you see it says count 0, and I try my green button. It's supposed to increase the count, but it does nothing. Of course, reset button also does nothing. So then my question was, well, maybe I did some wiring wrong, right? So I went back to GPZ. What value should I use for the pull down resistor? I was using 10K. And ChatGPT says pull down resistor, a value between 10K and 50K is generally suitable, right? I use 10K, so it's not a big, that's what we did. And it actually explains to me why 10K is more common. Great. But now look at the steps. Now it says connect one leg of the resistor between the GPIO pin 15 or 16 and ground. That is not how it told me earlier. Connect the button between the GPIO pin and 3.3 volts. Again, not how it said last time. So as you can see, ChatGPT makes mistakes and hopefully it corrects it every time you go along. And in fact, when I told it that the connecting the button to ground by a pull down resistor works, it actually explained that, yeah, it was incorrect and we needed to use the 3.3 volts to the button. So now I've fixed it based on what ChatGPT told me to do. So I go back and here's the fixed version. Now notice that it's a little more complicated connection, but basically what ChatGPT said, I needed to connect the button between the GP15 and 3.3 volt, which is over here. And then the other one we take with a pull down resistor to ground. After I completed this connection, this is the same code that ChatGPT created before. And after I connect and I run this, and now it works. I push the green button, count increases. I push the red button, count goes to 0. Beautiful. So that seemed to work. So this is our sequential design. As you can see, the code basically is one big sequence, about 38 lines of code. So it's pretty small. It did create a little function here. Notice that for update LCD. We're going to go more about these as we go into these videos. But it did create a function. But otherwise, most of it was sequential. It starts, it imports stuff, then it creates the I2C address, creates an I2C bus, creates the LCD, creates two pins for the count and reset. There is your counter, which is what's the memory for storing the count. And then it has this big loop where it basically continuously checking to see if with whatever button is pressed, and based on that, it's doing stuff. Great, works. There is a loop, but rest of it is essentially sequential. And the code is pretty simple. Give you that. So now let's go back to how do we do this in object-oriented method? Well, in object-oriented design, things get a little more complicated. So now what we have to do is start creating objects. We will talk more about what these things are as we go along. But as I was telling you that object-oriented design, you don't go sequentially. You sort of think about what are the different components and what kinds of things do they have. So we start with this counter. Counter is basically a number. What operations does it have? You can increment it, you can reset it, you can get the current value, whatever the value that it has. And that's what that object is. That's all it does. I don't care about where it's displaying things, what it's doing with it, but it's essentially the model of your counter that is simply one number with operations that it's doing. Let's look at the button. Again, the button has, in our design, has a pin and a name, and you can check if the button is pressed. When the button is pressed, you can send that event to a handler and things like that. So that's basically the button. And the LCD display, it needs to use an I2C bus internally, so it has that information, and it has operations like clear, show the text, have a specific row and column, and things like that. Notice that they're all created separately. I can create this LCD display class, and I can create it separately. I can test it separately without needing to worry at all about how it's going to be used. Yeah, we're going to use it for a counter today, but we can use the same thing for something else tomorrow. And that is really the key to object-oriented design. And then we put everything together using a controller. A lot of times you're going to hear about this design paradigm called model view controller, and that's what you're kind of seeing here. This class is our model. This is essentially the business model that does not rely on anything that it uses. These guys are views. This is what our users interact with. And this is the controller that kind of connects them together. So our controller has a counter, it's got a count button and reset button and displays things on a display. It has a run method that makes it do the things that it's doing. It has a button pressed and button release. I think I added one more method, which is not showing, but that's essentially what it is. So now let's see how that would look like in code. So what we're going to do is go back to Walkweed. And this time, we're going to use the object-oriented version. Notice that the first thing you would see is that we have completely cleaned up all that mess. We don't, nothing wrong with ChatGPT. It asked us to use an pull down resistor, but the Raspberry Pi Pico actually has an internal pull down resistor that you don't really need to use an external one. Fine, it asked us to use it. We used it, but for our purposes, we have totally simplified it. And you will see how simple it is. Everything else is pretty much the same, but let's look at the code here. The code, the main code, of course, is super simple, right? All we are doing here is we are importing some classes, and that's where all of our classes are. I'm going to show you that in a little bit. But basically what I'm doing is I'm creating an instance of our counter controller class, which is this big thing in the middle, this guy in the middle. And then I'm going to call the run methods to do whatever it does, let the controller run itself. And let's run it to make sure it still works. And it's basically doing the same thing. I push the button and the count increases. And I push the red button, count goes to 0. Works just like the other one, except that it looks completely different. So how did this magic happen? Let's take a quick look at the code. Remember that we haven't, for many of you, this is the first time seeing a lot of Python, particularly object-oriented Python. So don't worry about the complexities. We're going to address those in a little bit, but at least let's see how this magic happens. So here is my counter classes.py. And just like the diagram showed, our counter controller class is here, but let's take a look at the counter class itself. The counter class is basically has an initialization, and it's got 3 operations: increment, reset, and current, just like the diagram said it had, right? Diagram says counter has initialize, increment, reset, and current. And hopefully this class at least should not be too complicated for most of you. Initialization initializes the number to 0. Increment adds 1 to the number. Reset resets the number. Current gives you back whatever number it has. So that's pretty simple. Let's look at the controller. The controller has an initialize class. It basically initializes the display, initializes the 2 button, and initializes our counter model, right? And because we set up the buttons with a handler, we need to handle the button presses and the button release. We don't do anything with the button releases, but when the count button is pressed, we call the increment operation of the counter. When the reset button is pressed, we call the reset operation of the counter. After we did that, we update the display. Now, the update display is very similar to what the other update display has. And the run method, which is how we do everything, we first update the display, which basically puts the 0 in the front because initially the counter is 0. And then it does nothing. It essentially just makes sure that the application doesn't end. And all of the handlers is going to take care of the rest of it. Of course, there are additional classes like button. There's class for display that we're not going to go a lot over. And yes, they are sort of complicated, but we will talk about why they are written in a more object-oriented fashion for going forward. So um, that's quite a lot, right? For a simple counter operation, we probably had, even if I don't use those button and LCD display class from, other classes, there's still about 60, 70 lines of code. And if you include the button class and the LCD display class, there's probably over 300, 400 lines of code. Why? We started with the simple 35 lines using the sequential method, and just to do the same thing, we ended up having twice, maybe three, four, five times as much code. So instead of writing all this code, which is, as we said, just about 38 lines, we ended up having, a lot more code. So, so that's what we will try to answer in the rest of this course, right? It's a lot of code, so why take the trouble? Well, the thing is that life isn't as simple as the simple counter example that we saw, right? Yes, for a simple example, the solution was simple, but the problem is what would happen? The requirement changes. What do we need to maintain the code? How do we make sure that if things change, so tomorrow you give me a different problem, we have to basically start from scratch again because we can't reuse any of this sequential stuff that we wrote. How do we test the code? What if things change? How do we check if things were correct? So all of these are problematic if your design is purely sequential. So to give you a more appropriate example, let's think about counters that you see in the real world that is not the simple little click click counter, right? So if you're going into a parking garage, you're probably going to see counters there, right? As a um, car goes in, the counter increases or decreases depending on what this is showing. As a car comes out, the counter increases or decreases. So there are different operations, increase and decrease. There are multiple counts. You show a full when there is no more space available. That's a changing requirement. You could have, hey, a more complicated where you're actually counting the number of spaces in each floor of a parking garage, right? You can change completely how things work, that you're no longer just incrementing and decrementing. This is still a counter. It's a stopwatch, but when you press the go button, it's basically starts counting and keeps counting with the time. So all of these are essentially examples of the same counter problem, but as we go further and further, our requirements keep changing. But what is great with object-oriented design is that we can reuse a lot of the code that we wrote before, and we don't have to touch it, right? The button class, the display class, probably even the count class. All we have to do is add maybe an decrement method, and we can implement those multiple floor things very easily, right? And that's basically what object-oriented design does, that it makes sure that your code is better testable, and you can also implement more complex problems without having to start again from scratch. So we will be talking about documentation. You saw in some of the code that I showed that there is lots of comments and things like that. Going forward, in the examples, I'm also going to post the code that go along with these examples. Today, I just wanted to show what the difference is between sequential design and object-oriented design. And hopefully you got the basics of why object-oriented design is better than sequential design. So in summary, why do we do object-oriented? We obviously need to look at the different parts of the problem. We look at the different components. We need to figure out what are the characteristics, what properties does it have, what are the functions, what kinds of things does it do, And then once you have all of these different components, and then you can put them together, and we will see how you can create different objects. So for simpler applications, an object design may be an overkill. So if all you're doing is a little counter, maybe you do not need to write 300 lines of code for all of those classes. But if you want to design applications and you can build on your applications from one design to the next object-oriented design is a lot better. Hope this is useful, and we will continue in our future videos.